Welcome to Olympian Water Testing, giving you the best in water analysis. Today, we are looking at the NIH website, Copper in Drinking Water. The safety of the nation's drinking water needs to be maintained to ensure the health of the public. The EPA is responsible for regulating levels of substances in the drinking water, and copper can leach into the drinking water from pipes in the distribution system, and allowable levels are regulated by the EPA. The regulation of copper is, however, complicated by the fact that it is both necessary to the normal functioning of the body and toxic to the body at too high a level. So unlike lead, where just a little bit is harmful, especially to children, copper and conversely iron both have some health benefits, but usually you can get those just from your diet. Now, the National Research Council was requested to form a committee to review the scientific validity of the EPA's maximum containment level goal for copper in drinking water. Copper in Drinking Water outlines and the findings of the committee's review, and the book provides a review of the toxicity of the copper, as well as the discussion of the essential nature of the metal. The risks posed by both short-term and long-term exposure to copper are characterized, and the implications for public health are discussed. And the book is a valuable reference for individuals involved in the regulation of water supplies and the individual interests surrounding. So taking a look at the paper here, this is taking a look at the effects of excess copper and the cases and population-based studies. The human case of acute copper toxosis is presented in this section, and the city reports are by the NRC and the U.S. Agency for Toxic Substances and Disease Registry and the World Health Organization. So what do they find? Most human data on high-dose acute poisoning are based on cases of different intent with ingestion of copper compounds or accidental consumption of copper-contaminated foods and beverages. In such cases, it's difficult to estimate the quantity of copper consumed, whether it was formed in solid aqueous suspension or solution. It's also difficult to control for potential confounding factors such as microbial agents and their toxins. Following the acute ingestion of copper salts in the amounts that exceeded approximately, systematic efforts are generally observed. The effects include GI mucosal ulcerations and bleeding, acute hemolysis, hemoglobinuria, hepatic necrosis, and jaundice, neuropathy, azotemia, and oliguria, cardiotoxicity, hypotension, and the central nervous system manifestations, including dizziness, headache, convulsions, lethargy, stupor, and coma. The systematic sequelae of acute ingestion of copper salts are highly variable. Oral intake of ionic copper usually induces immediate nemesis, which reduces the quantity of residual copper available absorption from the GI tract. Now, acute copper toxosis manifested by hemolysis headache, febrile reactions, frustration, and GI symptoms was observed in one child after a solution containing copper sulfate was applied to burn skin during a debridement procedure. We can also see the different cases here. The CDC reported multiple outbreaks of copper poisoning from ingestion of contaminated beverages. So this can get into beverages, this can get in the water, and you can ingest it. Especially if you have Wilson's disease, this is a problem. While copper does have some health benefits, it can have some very big downsides. In most cases, the copper concentration was associated with illness in the excess of 30 milligrams, and a major incident occurred in 1993 to 1994 where 43 individuals became ill from a single point source in a hotel. Exposures were estimated from the range of 0.4 to 70 milliliters. So we can see a lot of experimental studies, Copper in Drinking Water in Pizarro, designed to study and determine a threshold and concentration for acute GI effects from copper in tap water. 6 healthy adult women of low socioeconomic status from Santiago, Chile, were randomly assigned groups receiving 1, 3, or 5 milligrams copper for 2 weeks, followed by 1 week of the standard tap water. Women prepared the test water every morning and recorded the water intake and GI symptoms, and the daily dose of copper was not reported. Nausea, vomiting, abdominal pain, cramps, or diarrhea, food intolerance was recorded. Of the 60 participants, 1 woman recorded nausea and 2 abdominal pain. 0 milligram copper of water and 1 milligram of copper of water. 1 woman recorded abdominal pain, only 2 recorded diarrhea, and only the recorded diarrhea and vomiting with 1 and all 3 symptoms. So, what does this say? While copper can have some health benefits, while it's not all bad, a lot of pipes are made of copper. Drinking out of copper can also have some adverse effects if it gets into your water, and definitely an over amount in it, whether it's ingested or whether you drink it or whether it's in your beverage, can still cause problems. That's why it's always a good idea to periodically test your water for high levels of copper.